Sampling techniques. Here we go. So a sample is defined as a subset of a target population that's observed to make inferences about that population. And the target population is defined by you, the researcher. The sampling frame is a list of members within that target population that, again, you as the researcher define. And sampling error is the degree to which the sample represents the target population. So if you have a lower sampling error, it means that the sample is more representative of the target population, and if you have higher sampling error, then it means that the sample is less representative of the target population. Rule of thumb, though, and it's important to note that just because you have a larger sample does not always mean that your sampling error will be lower. It's very important for people to understand that just because you have a larger sample doesn't automatically mean that it'll be more representative of the target population. It suggests that it is more representative, but that doesn't automatically mean that is indeed the case. Here we have a visual representation of what a sample is. So you define what the target population is as a researcher, and from that target population, you take a subset of that target population, and you call that the sample. So in sampling, you've got two basic umbrellas. First, you have the probability umbrella, and then you have the non-probability umbrella. Under the probability umbrella, you'll have random selection, whereas in non-probability, you'll have no random selection. Under probability, probability sampling, you'll have a sample that's representative of the target population, likely to be the lowest sampling error, lower sampling error than non-probability sampling techniques, which tend not to be representative of the target population and show a higher level of sampling error. Another thing to note, this isn't always the case, but often the case, that probability sampling techniques are usually used in quantitative research, whereas non-probability sampling techniques are usually used in qualitative research. So first, underneath that probability sampling umbrella, we have random sampling. This is where every member of the target population has an equal non-zero probability of being selected in the sample. So if in a hypothetical example, I have my target population, I've defined my target population to be professional athletes in the United States, and the sampling frame then would be the list of professional athletes in the United States. A random sample here would be every professional athlete in the US has an equal non-zero probability of being selected in the sample. And this random sampling has the lowest sampling error out of all sampling techniques. So this is thought to be the best sort of sampling when your goal is to reduce sampling error. Again, under the probability sampling umbrella, we have systematic sampling here, where every nth member of the target population is selected in the sample. N stands for any number that you choose. So again, if we have the target population as professional athletes in the United States and the sampling frame as a list of professional athletes in the United States, in systematic sampling, I might select every 50th professional athlete in the United States as part of my sample. Next, again, under the probability sampling umbrella, we have stratified sampling. This is where members of the target population are first sorted into relatively homogeneous groups. They're called strata, then randomly selected in the sample. Again, the target population, you're going to get tired of this because the target population stays the same, professional athletes in the United States. The sampling frame stays the same throughout this presentation, which will be the list of professional athletes in the United States. So here, a stratified sample would be professional athletes in the United States being grouped into gender strata, then selected in the sample such that there's equal representation from each gender strata. Now, cluster sampling is very similar to stratified sampling, and I'll show you why and how, more importantly. Cluster sampling, again, under the probability sampling umbrella, is when members of the target population are first sorted into groups, then certain groups are randomly selected in the sample. Seems very similar to stratified sampling, but I'll explain why they're different. Again, the target population, professional athletes in the U.S. Sampling frame is a list of professional athletes in the U.S. Cluster sample, an example of that would be professional athletes in the U.S. being grouped geographically, then only those professional athletes in New York and California are randomly selected in the sample. Cluster sampling sorts the target population into groups, making it similar to stratified sampling, but what makes it different from stratified sampling is that cluster sampling does not seek equal representation from all groups, from all strata, making it different from stratified sampling. Here we have a little bit of a breakdown because I've found that this is one of the more difficult concepts to grasp, so hopefully this slide makes it a little bit clearer. Stratified sampling versus cluster sampling, the similarities are that both you are sorting into groups, but the difference is that in stratified sampling you're seeking equal representation of groups, whereas in cluster sampling you are not seeking equal representation of groups. Again, the sampling umbrellas slide, I have this posted again, so this way we're transitioning from probability sampling techniques to examples of non-probability sampling techniques. Nothing new here, just the same slide as before. Now we're going to go into non-probability sampling techniques. Under that particular umbrella, first we have convenience or availability sampling. This is when members of the target population are selected in the sample based on convenience or based on availability. Again, target population, professional athletes in the United States, and then the sampling frame being the list of professional athletes in the United States. In convenience or availability sampling, you'd see professional athletes in the US who are present at practice when the researchers are visiting that are selected for as part of the sample. Next, under the non-probability sampling umbrella, we've got propulsive or judgment sampling. This is when members of the target population are actively and intentionally selected in the sample by the researchers through direct contact, sometimes before the research study is even designed. So once again, the target population being professional athletes in the United States, sampling frame being list of professional athletes in the United States. When we're doing propulsive judgment sampling, professional athletes in the United States are selected in the sample by being directly contacted by the researchers, let's say in this example, before the research study is designed. Not necessarily always the case, but that's generally the case. You design the study based on the sample that you'll have available to you for the most part. Again, under the non-probability sampling umbrella, now we have snowball or pyramid sampling. This is when members of the target population are continually asked to nominate other members of that population to be selected in that sample. So if you have the target population being professional athletes in the United States and the sampling frame being the list of professional athletes in the United States, the snowball pyramid sampling technique would be such that professional athletes in the United States are continually asked to nominate other professional athletes they may have connections with to be selected and participate as part of the research study as a sample, as part of the sample. Under the non-probability sampling umbrella, again, we have quota or target sampling. This usually stems from other non-probability sampling techniques first, and then once certain characteristic quotas are met, members of the target population who meet those characteristics are no longer sampled, while members of the target population who don't meet those characteristics are sampled. Sounds like a very long definition. I think the example here further clarifies everything, and taking it from a very wordy example to something that's hopefully easier to understand. So here we have again the target population being professional athletes in the United States, the sampling frame being the list of professional athletes in the United States, and a quota sample here would be professional athletes in the United States that are selected in the sample through other non-probability sampling techniques. But once the quota on, let's say, male athletes is met, that particular quota is met, now only non-male athletes continue to be sampled. Lesser known sampling techniques here, the next two. The first will be deviant case sampling, falling again under the umbrella of non-probability sampling. Here we have a sample of one-tailed outlier, which is just statistical lingo to say an extreme in one direction. So here again we have the target population being professional athletes in the United States, sampling frame being list of professional athletes in the United States. In deviant case sampling, professional athletes in the United States who weigh over 400 pounds or who weigh under 150 pounds are selected in the sample. The key word in deviant case sampling is or, right? So in deviant case sampling, I'm either selecting professional athletes in the United States who weigh over 400 pounds, or I'm selecting professional athletes in the United States who weigh under 150 pounds, or being the key word. Now, if we change the keyword from or to and, we come to intensity sampling. Under the non-probability sampling umbrella, we have here intensity sampling. It's a sample of two-tailed outliers. And the target population, again, staying the same, professional athletes in the United States. The sampling frame is a list of professional athletes in the United States. And an intensity sample would be professional athletes in the United States who weigh over 400 pounds and who weigh under 150 pounds are selected in the sample. So in this intensity sampling, what we have are athletes who weigh over 400 pounds and who weigh under 150 pounds, all within the same research study, versus diversity case sampling, where you have or either you're studying professional athletes in the United States over 400 pounds or professional athletes in the United States who are under 150 pounds. In intensity case sampling, you're studying both. Once again, just the same slide a third time, probability umbrella, non-probability umbrella, just for your reference. No changes here. Just a quick recap of what the umbrellas are, and also a recap of the visual representation of what a sample looks like. So here again, you have the target population, which you define, and then the sample, which, using the techniques that we've covered here, you'll be able to determine what kind of sampling technique you want to use and what your sample will be. Thank you very much.